In this lesson, we're going to look at the primary trigonometric ratios. I'll just abbreviate that to trig ratios. So we're looking at the primary trig ratios, and they apply to triangles. Before you do this lesson, I'd recommend you watch the calculator tutorial on how to use the trig ratios, sine, cosine, and tan in the proper method. If you don't use your calculator properly, you will not get the answers that you need in this unit. So our learning goals will be to determine the values of sine, cosine, and tangent ratios for a specific acute angle in a right triangle. So what is trigonometry? What is trig? So trigonometry is Greek for triangle measurement. It's basically the study of math that deals with proportions of triangles. And calculation based on proportions. So for any right angle triangle specifically, we're focusing on that here, right angle triangle, there are three primary trig ratios. And the three primary trig ratios are sine, which we just shorten to sin, sine, cosine, which we shorten to cos, and then tangent, which we shorten to tan. And if you go on your calculator, you're going to see those functions, sine, cos, and tan. They're usually pretty close to each other, depending on the calculator you have. So again, please watch this video to make sure you know how to use a calculator for this unit. Right now we're going to take a look at what the trig ratios mean in a right angle triangle. So again, we're focusing on right angle triangles. There are other methods that we can apply for triangles that are not right angle triangles, but specifically here, the trig ratios will only work when we're looking at the right angle triangle. Okay, so we're going to take a look at the sine, cos, and tan for angle A. This is a triangle here, a right angle triangle, and we're just going to label a few parts before we continue. So notice that the triangle has three vertices. The vertices are the points of the triangle. So this is vertex A, vertex C, vertex B. What you'll notice is we have three angles in the triangle as well. Typically, the way we name an angle in a triangle is we name it based on the vertex. So for example, the angle that's right where vertex A is would be angle A. And so we would call it, for example, angle A. Sometimes we use other symbols for angles. So you might see Greek letters like theta, for example. We might just put X in there to say angle X, but typically when you have a triangle that's labeled with the vertices, we would call that angle A. Over here, the 90-degree angle would be angle B. But we know what it is. It's 90 degrees, so we don't have to really look for it or try to solve for it. And this would be angle C. So basically, each angle will have a ratio using these trig functions, and I'll show you how to figure that out. So what we're going to do is we're going to label the sides. And the sides, when you label them, it really depends on what angle you're referring to. So first we're going to find the hypotenuse. The hypotenuse is always the side that's opposite of that 90-degree angle. So this is a 90-degree angle here. The hypotenuse would be right over here, hypotenuse. Now, the other thing I want to mention is that typically when we have a triangle, we can label sides with letters as well. Notice how this vertex here is uppercase B, while the opposite side of the triangle, which is a hypotenuse in this case, if you were to label it with a letter, we'd label it lowercase b. Likewise, if you look at this vertex here, that's A, the opposite side of this triangle, this side would be called lowercase a. And then this this is vertex C, so the opposite side of this triangle would be lowercase c. So right now we have the hypotenuse labeled, and right now we're going to focus on angle A. These sides are named relative to angle A right now. So the side, this side here, side A over here, compared to angle A, it is the opposite side. It is the opposite side. So it is opposite to A. And side C over here, compared to A, is adjacent to A. It's touching A. It's touching angle A. So side C would be the adjacent, meaning touching angle A. So relative to angle A, compared to angle A, side little a over here is opposite, and side C over here is adjacent. And so whenever we ask you for the trig ratios, you need to make sure you label your triangle based on what angle we're asking you for. So for example, if I ask you for the sine of angle A, the sine of angle A is always going to be opposite side over hypotenuse. And we can abbreviate hypotenuse as HIP. The cos of angle A is going to be the adjacent side over hypotenuse. So you need to remember that when I ask you for a sine ratio, the sine of angle A ratio, you're taking the length of the opposite side over the length of the hypotenuse. When I ask you for the cos ratio, cos of angle A ratio, you're taking the length of the adjacent side and you're dividing it or putting it over the length of the hypotenuse. And then for tan, you're going to do the opposite. So tan of angle A would be opposite over adjacent. These are your trig ratios. These are your trig ratios over here. So sine is always opposite over hypotenuse, cos of the angle is always adjacent over hypotenuse, and tan of the angle is always opposite over adjacent. How can you remember that? Well, there's a trick that you might have heard before. It's called SOHCAHTOA. Where S stands for sine, O stands for opposite, H hypotenuse. So sine is opposite over hypotenuse. Opposite over hypotenuse. C stands for cos, which is adjacent over hypotenuse. And T stands for tan, which is opposite over adjacent. So if you remember SOHCAHTOA, then you remember your trig ratios. So I'm going to redo this, but looking at angle B this time. We're going to rename the triangle looking at angle B. So I'm just going to redraw the triangle here. It's the same triangle above, I just made it a bit smaller because I don't have room here. So it is poorly drawn. We have side A, or we have vertex A, vertex B, vertex C. And I'm going to name the sides, so we have A, C, B, and actually we'll do it for angle C. We'll do the ratios for C, because we know what this is 90 degrees here. So we'll do the ratios for C, for angle C. So this will be angle C over here. And so I'd want sine of angle C. It's still going to be the same ratio, but we're gonna write down the ratios with the letters just to make sure we are seeing that we know what the sides are relative to angle C. So right now we're focusing on angle C. Let's name our side. So side B is always going to be the hypotenuse because it's opposite of the 90-degree angle, so that's not going to change. What is changing, though, is which one is our adjacent and which one is our opposite. So in this case, A is our adjacent because it's touching angle C. We're focusing on angle C right now. And C is our opposite because it's opposite of angle C. So notice how it just switched. We switched the spots depending on the angle we're talking about. So if I asked you for sine C, sine is so, opposite over hypotenuse. So we're going to take side C, so little c, over hypotenuse, which is B. I'm just writing the letters out instead of writing opposite over hypotenuse, just so we know what side we're looking at. If I asked you for cos of angle C, cos is ka, so adjacent over hypotenuse. So it would be A over C. Or A over B, sorry. Adjacent over hypotenuse, so A over B. And if I asked you for tan of angle C, tan is TOA, so it's opposite over adjacent, so it would be C over A, opposite over adjacent. Cos, adjacent over hypotenuse, sine, opposite over hypotenuse. And those would be your trig ratios for angle C specifically. What's the point of these ratios? Well, you can use these trig ratios to solve the triangle, to find missing angles or to find missing sides. And so we're going to take a look at how you would use these trig ratios in order to solve for missing sides and missing angles as we go through this lesson. We're going to do it in steps though. So first we're going to find basic trig ratios, and then we are going to work with our calculator to learn how to find angles from those trig ratios. So we're going to do it in little steps until we can build up to solve a full triangle. So we're going to start the example over here, find the three primary trig ratios for this triangle here. First thing I want you to notice, it is a right angle triangle, and we're going to do this for angle A specifically. So we're doing the trig ratios for angle A. So let's label our sides based on angle A. So here we have the side that's opposite to angle A is the one that's 5 centimeters. So this is going to be our opposite side. The side that's adjacent, touching angle A over here, is the 12 centimeter one. So this is our adjacent based for angle A. And the one that's opposite of the 90-degree angle, well, that's our hypotenuse. So that's the 13 centimeters. And so we need to find the primary trig ratios for angle A. So we're going to do sine of angle A. And we know that sine is going to be equal to your SO, opposite over hypotenuse. And if we just plug in our values for opposite and hypotenuse, the opposite is 5, and the hypotenuse is 13. And so you can leave it as a fraction. That's what I recommend you leave it as. But you could also just do 5 divided by 13, and then you'd get 0.3846, so on and so forth. So that would be our trig ratio, the sine trig ratio for angle A. You would do the same thing for cos of angle A, except cos is adjacent over hypotenuse. So we know it's adjacent over hypotenuse. In this case, for angle A, adjacent is 12. Hypotenuse is 13. So our cos ratio is 12 over 13. And our tan of angle A is equal to opposite, TOA, opposite over adjacent. So the opposite of A is 5. And then the side adjacent to A is 12. So 5 over 12. And these are your ratios for angle A in terms of sine, cos, and tan. I could have asked you for the ratios for angle C. You can try that out. And next video, I'll take up the ratios for angle C, and we'll move on to the other problems.